All right, so this is a different number pattern. This time it's still with pictures and numbers, but this time we're at a restaurant that's just opened up because of COVID and with their social isolating. These people might be a little snug. I think they're breaking the rules. So let's take a look at table one. All those little smiling faces are the people that get to go out and have dinner with their friends, so they can fit 4 around table one. And then if we add a second table, we can fit 2, 4, 6 people. And 3 tables, we can fit 2, 4, 6, 8. So the question for Erin is, what would the picture look like if there were 4 tables? So why don't you try to draw that, Erin? So she's drawing what she thinks 4 tables would look like in this case. All right, so what's that?
The 4 tables.
Okay, now what do we need to do?
Add the people.
Okay, you can just make them circles to save time. So here come the people. So how many people do we have at 4 tables?
10.
10 people. Okay, what if there were 10 tables? Would that be a picture you'd want to draw?
It would take a while.
It would take a while, so it would take too long. So let's see a trick on how to do. Okay, so in the first one, we had 1 table and 4 people. So then in 2 tables, we had 2, 4, 6. And then 3 tables had 2, 4, 6, 8. And then 4 tables had 2, 4, 6, 8, 10. So 4 had 10, and then if I was going to continue, 5, 6, 7, 8, 9, 10 tables, which is what I wanted over here. And let's see if we can figure out what's happening here. 4, 6, 8, 10. What's next, Erin?
12.
And then?
14, 16, 18, 20, 22.
So there would be, at 10 tables, 22 people. So the question here, to find the number of people, how would you do that? That's the tricky part. 1 table, 4 people. 2 tables, 6 people. 3 tables, 8 people. What's the pattern going on here? Any ideas?
I think for like the number of people, let's add 2.
So in this case, it's the number of tables. It's 2 multiplied by the number of tables, and then add 2. That's actually a very tricky algebraic rule. So the other way is you could say we start at 4 and we add some more. So let's just check out this thing though. What about 10 tables? So 2 multiplied by 10 plus 2. Is this going to work? 2 times 10 is?
20.
And then add?
22.
2 is 22. Would it have worked for 6 tables? 2 times 6 is?
12.
Plus 2?
14.
14. Whew, that's a tricky 2-step pattern. Okay, so to find the number of people, it's 2 times the number of tables, add 2, or we could just talk about it as the fact that this pattern is increasing each time. So this is a linear increasing pattern. Unlike the one with Brooke, this one is linear, also pretty tricky. So what we're going to work with today is going to be a little bit easier on your independent practice than either of these situations. So to finish my thinking on this, this pattern rule uses something called a variable. So we talked before it was 2 multiplied by the number of tables. Add 2 would give you how many people are at the restaurant. So the number of tables, we're going to use the letter T, a big capital T, can change. So there could be different amounts of tables, which would affect how many people there can be. So because the number of tables can change, here it's a variable, and variable comes from the word to change. So our equation is the number of people is equal to 2t, remember T is the tables, plus 2. So you can use this formula, this equation, for any number of tables in the restaurant. So how many people at 50 tables? 2, and I replace the t for tables with the 50 because there's 50 tables. So 2 multiplied by 50 plus 2 is 102. 2 times 50 is 100. Add the extra 2 people, 102. On the flip side, what if there was 40 tables? 2 times 40 is 80, plus 2, there would be 82 people if there were 40 tables. You could do it for 12 tables, 21 tables, any number of tables in the universe, you'd be able to find out how many people there are, as long as the restaurant was setting things up the same way.